8.7. In this sessions, we're going to look at radical functions. First, finding the domain of functions for the even index and odd index, and then graphing the radical functions. We saw that graphing the radical functions in 3.6, but I will review again for you. A little bit review of the conceptual part. We know that if the index of the radical is even, then the value of the radicand cannot be a negative number, right? Meaning this inside cannot be a negative number. So that means the value of the radicand must be greater than or equal to 0. If the index of a radical is odd index, then we don't really care what is the value of the radicand inside, except the restriction. So to find the domain of the radical functions, if the index is even, then we need to make sure the value of the radicand must be greater than or equal to 0. And that's how we're going to find out which x value will help us to satisfy this inequality. And it will become our domain. If it is odd index, the value of the radicand can be any number. So therefore, when we find the domain of the functions, so first example A, f of x is equal to square root of 6x minus 5 plus 2. Square root, so that tells me the index of the radical is even. So therefore, the value of the radicand must be positive. So this is how we start for even index to find out the domain. So to find out the domain, radicand must be greater than or equal to 0 for the even index. So what is my radicand in this case? Is 6x minus 5 must be greater than or equal to 0. So this tells us solving the inequality, my x value must be greater than 5 over 6. Writing this into interval notations, it must be 5 over 6 to positive infinity, which gives you this. Next, example B. G of x is equal to cube root of 5x minus 4. Since this is an odd index, the value of the radicand can be either a positive or negative, so we don't really care. And since 5x minus 4 has no restriction, meaning that it's not going to make it anything undefined, so therefore the domain of this cube root function is negative infinity to positive infinity, right? It could be any real number. So quickly look at example D. Again, the index is cube root, so I know that the value of the radicand can be both negative or positive number. So for this particular one, because of the radicand is a fractions, it could be any number except what? Negative 3. Because if it is negative 3, you look at it, negative 3 plus 3, that will become 1 over 0, which is going to be undefined. So that's not good. So we do have a restrictions in this case. Therefore, for this case, domain of this cube root function will be anything except -3. So the way that we write it down will be what? Negative infinity to -3, not inclusive, union with -3 to positive infinity. So everything except -3. But however, if it is an even index, we need to follow the theoretical systematic part, which is the radicand must be greater than 0. So for the next example C, to find out the domain of the square root, so my domain must be radicand is greater than or equal to 0. So when I substitute the radicand, that is 4 over x plus 3 is greater than or equal to 0. Hopefully, you recall, okay, after we talk about this example, you recall how to solve rational inequality. So see, the conceptual part is only this. Everything after that becomes what we learned before. So how do we solve this rational inequality? We need to find out the critical point. The critical points are basically the 0 and undefined restrictions. Okay, restrictions. So since the numerator is 4, we have no zeros at all because 4 will never become 0. But we do have a restriction because in the denominator, x cannot be equal to -3. Now that I got the critical points already, I can use this critical point to break into interval. So which allow us to get interval 1 and interval 2. Now we're going to pick a number from each interval and then testing it. So I pick -4 and then I pick 0. So when I substitute, remember that restriction is never included, so it will be open circle, right? So when I plug it in -4 to this inequality, 4 on the numerator is 4, which is a positive number. When I substitute -4 in the denominator, it will be -4 plus 3, which is a negative number. Positive number divided by a negative number is a negative number, which cannot be greater than 0, so therefore this is not good. On the next case, when I substitute 0, on the numerator is 4, so it will be always positive. When I substitute 0 into denominator, 0 plus 3 is also a positive number. So a positive number divided by a positive number is a positive number. And we know that a positive number is greater than 0, so this is a good. So therefore, now I can conclude that my domain will be starting from -3, all the way to positive infinity, because this is the one that is going to be true, right? And then 3 is not inclusive, and then we always use parentheses for the domain part. Graphing. When we graph, we want to find out the domain and then find the solutions, which is order pairs, and then plug it in. Let me recall for you, if you are graphing the even index function, like square root functions, what we need to know is the starting point. So how do I get the starting point? First, you find out the domain. That means we are interested in looking at the radicand must be greater than or equal to 0. In this case, my radicand is x, so x must be greater than or equal to 0. So therefore, that tells me from 0 to positive infinity. This is my starting point. Hopefully you recall this from 3.6. Second step, once we know our domain and the starting point, I'm going to use that starting point to find out the solutions. So my starting point is 0. So when I plug it in, 0, right? F of 0, that is square root of 0 equal to 0. And the next number that I'm going to use is 1 because that is a perfect square number. F of 1 is equal to square root of 1, which is 1. The next number that I'm going to use is f of 4, right? Because square root of 4 is equal to 2. So hopefully you remember this. Square root of 9 is equal to 3. So now I got these points to plug it in and then graphing it. So the third step will be graphing. So first step, find the domain so that it will give you this starting point, and use the starting point to start the plotting points. So now I have my graph will become, at 0 will be 0, at 1 will be 1, at 4 will be 2, and at 9 will be 3. And remember that the square root graph is a parabola halfway. So here's the trick, right? You need to remember that if it is a square root graph, find the domain first. That will give you the starting point, and then using the starting point to plot in the order pairs, find the solutions, and then graph them. And this is the parent's graph of the square root. Next, cube root. For the cube root graph, this is what we're going to do. 1, because we know that cube roots, the domain is all real number, right? A negative infinity to positive infinity. So first, what we're going to do is, for the cube root, we find the center. How do I find the center? That is basically when the radicand is equal to 0. So in this case, x is equal to 0. That's my center. Now I'm gonna plot the points, and first I'm gonna have to plug it in my center. 0, that's my center. So I know that f of 0, that is cube root of 0, that will give me 0. Now I'm gonna find out the points on the right hand side of the center. 1 is another perfect cube number, so cube root of 1 is 1. And another perfect number is 8, which is cube root of 8, that is equal to 2. And then I go to the other side of the center, which is f of negative 1, because cube root of negative 1 gives me negative 1. And f of negative 8, that is cube root of negative 8, that me negative 2. So I got negative 1's negative 1, and negative 8 give me negative 2. Now we plot these points to get my graph. So at 0 will be 0, at 1 will be 1, and at 8 will be 2. And negative 1 will be negative 1, negative 8 will be negative 2. And remember that this middle 3 point is not a straight line, it's a curve, so it will be going like this, and then going like this. This is the cube root of x graph. So this is also the parent graph of the cube root. Let's move on to the next example. Hopefully you get better as we move along. So first we need to recognize what radical functions we are talking about. In this case is what? The even radical functions, square root. So for the square root, first we're going to find out the domain. The domain is basically the x value which can make the radicand greater than or equal to 0. So in this case, my radicand is x plus 2 greater than or equal to 0. So that tells me x is greater than or equal to -2. So my domain is from -2 to positive infinity. And this allows us to see where is my starting point is. So once I know the starting point, my step 2 is basically what? Find out the order pairs, the solutions from the table. Using the starting point, -2, and we're going to continue. So from here, h of -2, that is square root of -2 plus 2, which is going to be square root of 0 equal to 0. So we got 0. The next value that I'm going to pick is basically the next perfect square number, which is the next perfect square number that's greater than 0 is 1. So the only number that's going to work to get 1 is when x is -1. So when x is -1, that will become 1. The next one will be, we want another perfect square number, which is 4. So I must pick 2, because only if you pick 2, 2 plus 2 will become 4, and the square root of 4 is 2. Finally, the next perfect square number that I want to use is square root of 9. So the only way that I can get 9 is picking 7. So 7 plus 2 is 9. So square root of 9 is 3. So I got this. So finally, I got the points to graph, enough point to graph. So at -2 will be 0. At -1 will be 1. At 2 will be 2. And then at 7 will be 3. So I got my curve right here. Next example. Again, noticing that this is a square root. So first I'm going to find out my domain. So for the domains, the radicand must be greater than or equal to 0, which is my radicand is x minus 2 is greater than or equal to 0. That gives me x is greater than or equal to 2. That tells me my domain is from 2 to positive infinity, which allow us to see the starting point. So next step, using the starting point to find out the order pairs. And for this time, I'm just going to do mentally. Make sure you write it down like in a previous example to do the computations. When I plug it in 2, 2 minus 2 is 0, square root of 0 is 0. The next number that I'm going to pick is 3, because 3 minus 2 will give me 1, square root of 1 is 1. The next number that I'm going to pick is 6, because 6 minus 2 is 4, square root of 4 is 2. And finally, the next number that I'm going to pick is 11, square root of 11 minus 2 is 9, square root of 9 is 3. So finally, using these points, I can graph it. That will be 2, 0. At 3 will be 1. At 6 will be 2. And 11 will be 3. So I got my graph like this. Next, for this one, it is the cube root. So for the cube roots, first thing that we need to find out is the center. How do I get the center? When the radicand is equal to 0. So that basically tells me, in this case, my radicand is x, so x is equal to 0. We got the center. So using the center, now I'm going to plot the points. So here's my center, 0. Plug it in. F of 0, that is cube root of 0 plus 2. That is 0 plus 2. That gives me 2. The right side of the center, a perfect cube number, is 1. So that will be cube root of 1 plus 2, which is going to be 1 plus 2. That gives me 3. Now the right side of the center is perfect cube number is 8. So cube root of 8 plus 2, that is going to be 2 plus 2, which is going to be 4. On the left hand side, we pick negative 1. So cube root of negative 1 plus 2, which is going to be negative 1 plus 2. That will be 1. And the next will be negative 8. So it will be cube root of negative 8 plus 2, which is negative 2 plus 2. That will give me 0. Now, we can graph this, which is at 0 will be 2. At 1 will be 3. I wrote it wrong. At 8 will be 4, right? At 8 will be 4, so make sure you fix that. And on the left hand side, at negative 1 will be 1. And then again, I wrote it wrong right here. It should be negative 8, right? At negative 8 will become 0. So we got a cube root graph like this time. Finally, the last graph. For the cube root functions, once again, 1, you need to find out my center. So in this case, how do I get the center? The radicands must be equal to 0, which is x must be equal to 0. Once we know the center, that's where we're going to use the xy chart to find it out. So plug it in, h of 0, that is negative cube root of 0, which is going to be 0. If I plug it in the next one, 1, that will be negative cube root of 1, which is going to be negative 1. The next right perfect cube number is 8, so negative cube root of 8, that gives me negative 2. On the left hand side, that will become h of negative 1, so negative cube root of negative 1, that will be my negative a negative 1, which is going to be a positive 1. Lastly, picking negative 8, that gives me negative cube root of negative 8, which is going to be negative of negative 2, which is when I pick negative 8, that will become a positive 2. This allows us to graph. At 0, 0 will be right here. At 1 will be negative 1. And at 8 will be negative 2. And negative 1 will be 1. And negative 8 will be positive 2. So basically, the graph flip around. So this will look like this. And this concludes this sections. And make sure you remember that if it is a cube root functions, right? Let me go back and recall. If it is a square root functions, you need to find out the starting point, which is looking at the domain, find out the domain. If it is a cube root functions, when we graph it, we want to find out what is the center when the radicand is equal to 0. And this concludes our session.